Okay, welcome everyone. This is we are going to discuss about the pre-calculus topics, and we'll follow for this the textbook by Michael Sullivan. Our today's discussion topics is number system because, as we all know, mathematics actually based on numbers developed, and we can also in other way we can say actually numbers are the pillar of mathematics. So we'll talk about the numbers system, and number system in a sense actually real number system, how it's developed and its subsets. So better we talk about real number system. Okay, so we are confused a little bit. So what is real number, mainly we discuss. So we need to have a very clear idea about the number system. So I'm Professor Dr. ABM Shahadat Hossain, working at Department of Applied Mathematics, University of Dhaka, and this is my platform, CMDA, Center for Mathematics Development Alternatives. So this video will actually help people to understand mathematics better, I hope. So let's begin. We are first we write a list of numbers, and let's say 4.3.001 and it's 13 by 6 pi e or 10 to the power 5. So we have few numbers, and we are familiar. You want to actually discuss how these number systems are developed up to the real number. And before Jesus Christ, people are actually used to count their stuffs like goats, cows. They use stone and or sticks. But after when the language actually discovered, then people give some symbol for these numbers. So first set of number that mathematician developed before the Christ, maybe it would be more than 2000 years ago, and the numbers we call it counting numbers. Okay, so at the beginning it was a counting numbers, and counting is the natural for everyone. So we these numbers mathematician symbolized as 1, 2, 3, 4, and so on. So this set is known as counting numbers, and it is written by this symbol. This symbol is defined by AMS, American Mathematical Society. So we call it natural numbers. So the natural numbers. Okay. So or simply naturals, we can say. So natural numbers are actually counting number. So for example, we can say I have I have 1,000 taka in my pocket. I have 5 pairs of shoes, blah blah. So this number, if we observe, so zero is not a natural number because we cannot say just zero. I have 0 taka or zero dresses. So zero is not at the beginning. So if we observe here, we have few things like if we observe here. So if we add any two natural number, it's again a natural number. Oh, and if we multiply any two natural number, it's again a natural number. Like 2 plus 4, 6, 6 is again natural, or 1,000 plus 5, then 1005 is again a natural number. So simply we can say that n is this is valid on this operation. So or We can say addition and multiplications are valid here. So this is the property. And now mathematician faced a problem like if you have solved a question here, solve the equation x plus, let's symbolize 7, equal to 0 in n. So this means find the natural solution of this equation. And when we are going to solve this equation, we found actually a very simple process. So we get actual minus 7. This minus 7 number does not belongs to the set n. That means it's not a natural number. So the symbol here, bar epsilon, this known as this symbol is known as does not belongs to not, or simply can say not in. Okay, so mathematician realized that there are some number which has negative signs and zero as well. If we subtract 5 minus 5, then we get a 0. So 1, 2, 3, 4. We have already this number as natural number, and mathematician they added more numbers with this set like 0, minus 1, minus 2, and left side go on. So this set of number, they call it set of integers. So we got a bigger set of numbers, which is denoted by the symbol Z. And so these are integer numbers, or we can simply say integers. Again, we'll see uh, what operations are valid on this set. So you can clearly see that if we add, subtract, and multiply any two integers, it's again an integer. So addition, subtraction, and multiplications are valid for this set. But mathematicians realize when they faced a problem, solve the equation. That's 2x plus 3 equal to 0 in z. So find the integer solution for this equation. And what happened? It clearly we can see that if we solve this equation and we get x equals to minus 3 by 2. So this is a different kind of number, ratio of two integers. That's the minus 3 is an integer, 2 is an integer. So this number does not belongs to the set Z. Okay. So we have a question, and mathematician they understood that every integer can be written in this form. So 4 divided by 1, like 3 divided by 1, 2 divided by 1. So every number can be written like this. In fact, in between two integers, there are fraction numbers. So they developed a new set where actually like say in between 0 and 1, there are 1 by 3, you can say half, or you can say 3 by 4, and so on. How many unlimited fraction number like this? So by this way, so we cannot actually um, uh, we can actually write so many numbers in this way. So this set is a set of rational numbers. So better we are not defined in this way. We actually write in this builder form. So the previous sets we define is tabular form where elements are separated by comma. Now builder form we will write by one notation to introduce the elements. So P by Q, where P and Q are integers and Q is not equal to 0. And so we got a larger set, which is known as a rational number. So rational numbers, so you can easily say rationals, right? Okay, rationals. Now, we can observe here that, like in rational cases, if we add, subtract, or uh, multiply, even divide, division also, these operations are valid on this case. And so all these four operations are valid. That means if we multiply or divide or any two rational number, it's again in a rational numbers. But still, a mathematician faced problems. So like solve equation like this is equal to 0 in Q. So it means find rational solutions of the equation. But let's see what we have. We have here x squared equals to 2, and then x equals to plus minus root 2. So does root 2 belongs to Q? That's the big questions. And to understand this, we have to understand the rational number in more details. So like if any rational numbers we can see in decimal form. So if we convert in decimal form, decimal, so decimal, like some rational numbers like 5 by 2, for example, we get 2.5, which is finite decimal. Some numbers like 10 by 3, and then we got 3.333. So this is finite decimal, finite, but this is infinite, infinite, and we can say actually we can write this as a 3.3. So there is a repetition. So we call it non-terminating, non-terminating, but repeating. Okay, but what about root over 2? Root over 2, if we say what about root over 2, you can use, see the calculator. Let's use the calculator. So calculator will give us the answer. Also, you know that it's like 2 decimal 1.41, but if you will want to know 2 and then square root, see how many digits we have. So there is no repetition. Even if you ask the computer programming, then it can give you the billion, million decimals, and it's also infinite decimal, but no repetition there. So this is non-repeating, and so this number is non-repeating, like 1.41, and we can say the other digit. You can write 421, but we cannot guess what would be the next digit, blah blah. So this is different kind of numbers which we can say non repeating and non terminating. So this set does not belongs to the set of rational numbers. So mathematicians, they actually discovered that there are such numbers which are non-repeating and non-terminating. So like any square root of any numbers, non-square numbers, particularly pi, e, so which actually known as irrational numbers. Irrational numbers. Okay, and the American Mathematical Society, they denote it by the special letter Q star. Now, so irrational numbers in decimal form, it is also defined. You can say this is also valid for all four operations: addition, subtraction, multiplication, and divisions are valid here, and it is a non-terminating and non-repeating numbers. Non-repeating decimals. Okay, so if we convert in decimal form, then we get this characteristic quite different from this rational numbers. Rational numbers, if it is non-terminating, then we found it is repeating, uh, and so, but in this case, non-repeating. So far we got we discuss natural number first discovered, and then for necessity mathematician discovered integer numbers, so including zero, and then we have a ratio of two integers, fraction number, which we called here rational numbers. Okay, rational numbers, and then there are some types of number irrationals. So what is real number then? So far a mathematician actually then defined the real number. Real number is actually simply the collection of all rational and irrational. That means Q union Q star. So it is denoted by this. So this is are called real numbers or simply real. So if we show these by some box, so first mathematician we have a small set of numbers. As all are infinite, but these are counting numbers one, two, three. So this is the box, and then it is we get a larger box which includes n, z, so including 0, -1, -2, and then again we get a more larger box which is q, and q is just a ratio of two numbers, and q cannot be equal to 0, and we get a separate set of numbers which is q star irrational root 2 pi a, and so mathematicians they got a more largest box which actually the real number. So this is the case, and we can find real number. So real number, how can we define is real number in one sentence? That is very important. So if you say all this number can be written in decimal for natural, integer, rational, irrational, like integer -2 can be 2.0. So reals, we can say a number that can be represented in decimal form. Okay, so these are the number, but particularly, so we can say, so any number can be. So what type of number these are? So go back to the our list. So what we can say here about these numbers? So we can say 4. What about 4? This is natural. This is an integer. This is also rational. This is also real. What about this one? So finite decimal. This is definitely rational number and real number. What about this decimal? So this is rational, real. This is also rational and real. Pi irrational number, but in broad sense real. E, this is 2.71, and it is also non-terminating and non-repeating rational. What about 10 to the power 5? 10 to the power 5. So that means from 1 we have got 5 zeros. So this is natural. We can say it integer. We can say it rational, and then we can say it also real. So this is all about different types of numbers, 10 base numbers that we talked about. But number system developed actually 3000 before the Christ, and that was 60 base number. And still we use this concept like 60 for 60 minutes equals to 1 hour, 360 degree in this case. So we're not going so details, but so far we understand the real number. That number can be present in decimal form. Okay, so lastly we talk about, still we have a questions here. What questions solve? Does every equation has a real solution? Like if we have this equation 0, so does this equation has a real solution? And sorry, real solution, is there any solution in R? And the answer we found x square equals to -2. So this actually gives us a property of any real number. If any number x in R, that mark, then it implies square must be greater or equal 0. So this violates the property of real numbers. So what will happen then? X equals to plus minus root 2 over minus 2. And then mathematician found that this number does not belongs to R. This is a new kind of numbers, and they use root 2 over minus 1 equals an imaginary unit. So this is an imaginary number. And so finally, if I ask a question, if every real number is an um, this type of number, and this type of number, a new set, actually set of complex number which can be written a plus bi, and a such that a and b belongs to the R. A is the real part, b is the imaginary part, and I is the imaginary unit. Now, can we write in decimal form root over 2I? We cannot. So that's why we say real number is a number that can be represented in decimal form. Now, last point we want to talk about, if we say every real number, question, every real number, every every real number is complex. So this is set of complex numbers. So every real number is a complex number. If I write this statement, is it true or false? True or false? So answer is true. True. Why? Because we can write 5 as equal to 5 plus 0 into I. So you can every real number can be represented in this form. So this is the most larger number, complex, but complex number cannot be written as, but the other way around, every complex number is real? No. So we found this relation on these all sets, like we got first developed the set of numbers, which is actually subset of Z, and Z is a subset of Q, but we found a different set, which is actually disjoint. If we intersect these two, this will be an empty set, but then we found a set R, which is actually the union of rational and irrational. And still, then we found another bigger set, which is a set of complex numbers. So we can follow this sequence subset. So every natural number is a complex number, every Z is a complex, every Q is a complex, every Q star is a real or complex. We can say so ultimate goal. But in pre-calculus or calculus case, we only consider up to real numbers. So thank you for watching this video, and I hope this would help you to understand the number, a different type of numbers in a very clear way. And feel free to comment on this video if you want more this type of video. Please uh, give some comment on this, and thank you so much. Bye.